Hello, this video is the solution to the functions portion of your review packet for your semester 1 final. Feel free to skip around and watch the parts that you need to. It's not required that you watch the whole thing. So question 1 says determine if each relationship is a function. So if we're talking about just general functions, the biggest thing to remember is that you only want one y for each x. Or some of you guys say, don't repeat your x's. So what I'm going to look at is I'm going to look first here at what I have in my x values and to see if any of them repeat. So here I only have 1, 1, 1, 2, 1, 3, and 1, 4. I'm good. Each x has its own y. So this first one is a function. All right, let's look at B. I'm going to again look at my x's. Some of you guys might be a little thrown off because you see here that 120 is repeated in the y's. It's okay if the y's repeat. It's the x's we want to check. So here I see 1, 2, 3, and 4. Nothing repeated in my x's, so it is a function. Looking at C, I see I have a 1 in my x column, but then I have two 2's. That is not okay, so it is not a function. Alright, so question 2 says determine if each graph is a function. So the big thing we use here is the vertical line test. You guys can just do kind of a sketch of a vertical line, or you can use a ruler to see if it passes the test. Remember, once it fails, it's failed entirely. So I might check a couple here on A. So far, it's only hitting once. As long as it only hits 1 point each time, it's passing the vertical line test. So this first one, after I just wrote all over it, is a function. Okay, let's look at our second one again. I'm looking at it, drawing some vertical lines. It should only pass my graph once. It is also a function. Now I'm getting to this oval shape here. And as soon as I draw a line, I see it hits twice. It hits once there and there. So at that point, it's failed, and this graph is not a function. I don't have to check anywhere else. And I'm going to check my last one, D. Draw just a random line. I can see it hits 1, 2, 3 times. So even already that one is also failed, and it is not a function. Okay, moving on. It says, given that f of x equals 3x plus 1 and g of x equals x minus 5 squared plus 2, A says evaluate f of 0, f of 10, g of 0, and g of 10. So this, or these equations, are written in function notation. We know that because there's an f of x there instead of our usual y. Remember, f of x is the same thing as our y. So if it says find f of 0 or evaluate f of 0, it's saying plug 0 in for x, or for your input, and tell us the output. So you can see I set it up already for f of 0. So on the right side I have f of 0 equals 3 times 0 plus 1. So wherever I saw x, I put 0 in. So if I simplify that, I can see f of 0, well 3 times 0 is 0 from right here, plus 1 would give us 1. Same thing for f of 10. So f of 10 would be 3 times 10 plus 1. So f of 10 would be 31. Okay, you can do the exact same thing for g of 0, but with g, right, that's a g for here, I'm going to use the equation that's g of x. So I'd have g, let's do g of 0, is equal to 0 minus 5 squared plus 2. Well, 0 minus 5 is negative 5. Negative 5 squared is 25, so plus 2, and g of 0 is 27. I'll let you work g of 10 out on your own just because I'm running out of room here. Let's look at B, which says find x when f of x equals negative 8. So if you read this really carefully, it's saying find x. So if they're asking us to find x, we must have our y or our output. So this is what we're going to replace f of x with. So for B, let's work on B here. I'm going to have negative 8 is equal to 3 times x plus 1. So I'm solving for x, or I'm working backwards. So once you guys get this set up, you all know how to solve it. So 3x divided by 3. So x is negative 3. C is the exact same thing. So it says find x So we know we can't have x if we're looking for it if g of x equals 6. So if I'm looking for g of x, make sure you're using the equation g of x up here. So I'm going to have 6 is equal to x minus 5 squared plus 2. I'm going to subtract 2 first. I get 4 is equal to x minus 5, that's still squared. Square root it. Be careful here, square root of 4 is a positive and negative 2, and that's equal to x minus 5. Remember, 2 times 2 gives me 4, and negative 2 times negative 2 gives me 4. So then I have to solve both equations. So I would have 2 is equal to x minus 5, and negative 2 is equal to x minus 5. So add 5, add 5. So x could equal 7. Add 5 in my other one. Or x could equal 3. So there's 2 solutions here for C. Alright, looking at a graph now, it says refer to the graph below of the function h of t, where h is the height of a ball in feet and t is time in seconds. So A says what part of the domain is pictured. So I put a little note in there right away. Domain is what is our x values here. So I always look at my graph, I go to the far left side to see where my graph starts. Well, my graph starts right here, and I know x is 0 there. Okay, my graph stops right there at that point. I'm going to erase it so I can see those numbers, but right at that dot there, and x is 2.3 there. Now this is a continuous graph because it's a line, so we write our domain as an inequality. So my minimum x value is 0, so x is greater than or equal to 0, and it's less than or equal to 2.3. So I'm going to do B in blue for the range. Same thing, but I'm looking at my y values. Well, my minimum y value is at the same point here, but y is 0. And then I need to know my max y point. Somewhere right here. I said y was about 26. So now, inequality again. So minimum of 0. Y can be greater than or equal to 0, but it has to also be less than 26. Alright, so C says what is the value of h of 2? So this is function notation again. So remember that when it says what is the value of h of 2, 2 is our input, it's our x. So I'm going to go over to my 2 on my x-axis right there, follow it up, go over and figure out what y is. So I need to erase that pink. It looks like it is 10 is my output. So value of that is 10. D says what does h of 0 represent? So h of 0 is this first point right here. Our input 0, or our x is 0, and our output's 10. Well, if we're talking about the height of a ball, which it tells us up there, h of 0 is the initial height that the ball is kicked from. So at 0 seconds, when the ball is just getting kicked, we're at a height of 10. Okay, let's look at E. What does h of 1 represent? And I'm not writing out the answers for D and E, but you guys can write them down as you go. E says what does h of 1 represent? Only thing different here is now our input or our time is 1 second. So h of 1, right there, is the height of the ball after 1 second. Okay. F says when does h of t equal 0? Alright, so this is where we have to be careful again. So what this is saying is that our output is 0. Remember, our output's like our y, so what I'm going to do is I'm going to look where y is 0. So I'm going to do some erasing here so we can see some information. Looking where y is 0, well, y is 0 right along here. So I'm looking for where that graph crosses, which is right here. That was at that 2.3. So when does h of t equal 0? Well, for f I'd say at 2.3 seconds. Alright, for each graph shown below, state the domain, range, and value of f of -1 and f of 2. So I put a note in right away. The graph in A is discrete, and I know that because it's just dots, they're just points, and they are not connected. B and C are different. I can see that those are curves or lines, and it's connected. It's not just points, and we call that continuous. That's important because our domain and range are written differently if it's discrete versus when it's continuous. So let's start with A for discrete. Let's look at our domain. So I'm going to do D for domain. Remember, domain is our input or our x's. When it's discrete, we use those little brackets and we list our x values. So if I start at this point here, The x value there is -2. X value for that point right there is -1. X value there is 1. And then, nope, sorry, let's back up. Should be a 0 in there. So it should be a 0, 1, and 2. Now that my domain is done, let's look at our range. I'm going to try to write a little smaller here. Range is our y's. So if I look here, I can see that these 2 points share the same y value. I only have to write it once, so -3. These two share the same, which is -1. And then this one has this one right here has a y value of 1. Okay, and then it says f of -1. You got to find it. So remember that's saying if our input is -1, what is our output? So f of -1, I'm going to go to -1 on my x-axis. That's this point. My y value is -1, or my output. F of 2, I'm going to go to 2, go down, that's this point, and my y value is -3. Alright, let's look at B. We have a curve here. I'm going to start with my domain again, still my x's, but now I have to write it as an inequality. So I'm going to look to the left. Here's my minimum x value, -2. Max is, oops, that's a little curvy right there. But my max x value is that 2 right there. So I'm going to have -2 is less than or equal to x, less than or equal to 2. Do the same with my range, but I'm going to look at y's. So it goes from -4 up to +4. -4 is less than or equal to y, less than or equal to 4. And then it says f of -1. So let's find our f of -1. So -1 is there. So that's, well, it's kind of a decimal. It's about in, I'm going to circle the area for you here. F of -1 should be right in here where x is -1. I said about -0.5. And then f of 2. That one's easier to see if I erase up here. F of 2, well, that's right over here, and y is 4. And for our last one, same thing, domain is going to be an inequality. X goes from -3 to 2. Let's look at our y's. Goes from -3 to 3. And then f of -1 looks like it is 1. It's kind of right there. And f of 2 is right here at the end, and that is 3. And then we have some matching, so choose a graph that best represents each situation. So I like to kind of look at the graphs and read the descriptions as I go. So A says a person leaves home, drives through town, then on the highway, and finally stops at a rest area. So if they leave home and drive through town, they're picking up, or they're getting farther away, so distance is on our y. They're getting farther away, then they go on the highway, they're probably going faster and getting farther away from home, and then they stop, so they never went back. I'm going to go with A right now. Let's look at B, and we can always change them. So a person leaves home, drives to the other end of town, and buys groceries, and returns home. So what that tells me is they leave home and they drive to the other end of town, so they're away from home, but then they come back. C is the only graph that shows that. And then let's look at C. Says a person walks to a friend's house where she stays overnight. So this person didn't come home. They walked and then they stayed somewhere. So that looks like it goes with graph B. One more matching. So this time we're talking temperature versus time. So it says, A says that the temperature of the water in a glass remained constant. Well, constant means no slope, or slope is 0, so it's a flat line. That's got to go with B. The temperature of the water in a glass rose steadily for several hours until it reached room temperature, then remained constant. So if it rose, that tells me it's going up. The only other one that's going up, or the only one in general, is C. And then the temperature of the water in a glass cooled down steadily with the addition of ice and then remained constant. So if it's cooling down, the temperature should go down. That should go with A. If you have any other questions, please email me or ask in class or stay after so you can get help. Thanks.